We are going to be looking at piecewise functions today. So in the notes, if you want to try those warm-up questions, those are review questions from the previous assignments with parent functions and doing transformations of parent functions. But today, we're going to use those parent functions, but we're going to take pieces of them, put them together, and create a piecewise function. So this is an example of a piecewise function of equation of one, and this should just be one big bracket. And so we have two different equations combined into one function. So we have an equation here and we have an equation here, but we're going to be using this equation only for these x values when x is less than 2. And then we'll be using this equation for when x is greater than or equal to 2. So if we are evaluating our function at x equals -3, you first need to look at these two on this side to figure out where does x equals -3 fit. Does that fit into the first piece or does it fit into the second piece? And since that is an x value that is less than 2, that's going to fit into the first piece. So since -3 fits in here, we're going to plug it in right up here. So instead of x minus 1, that's going to be, so if I take my function, plug in a -3, that's going to be -3 minus 1. So plugging it in right here for our x value. You simplify, and it's -4. So that is our y value when x equals -3. We do the same thing here, f of 7. So we take this, we figure out, okay, 7 is a number that is greater than or equal to 2. So it's going to fit into the second piece. So then f of 7, we plug it into the second piece, so it becomes 2 minus 7. Since we're plugging it into that x, we simplify, and that equals -5. The last one, f of 2, so we look to see, okay, 2, does that fit into this top piece or the bottom piece? And since this one has the equal to sign right here, it has to fit into that bottom piece. So equal to, this is just less than 2, but this is greater than or equal to 2. So it fits into the bottom, so 2 minus 2, which is 0. Now we're going to be graphing this function. So I'm going to take a few more numbers to plug them in. And so usually when I graph a piecewise function, I take like the top piece and I make a t-chart for the top piece. So this is going to be for x minus 1. This is the t-chart for this part. But remember, this is only for x values that are less than 2. So I'm actually going to plug in a 2, even though it doesn't include 2, but it's everything up to but not including 2. So that's going to be an open circle when I graph that. And then I'm going to plug in some more x values that are less than 2. So like 1, 0, -1. Plug those all into my function. So I plug these all up into this function up here, x minus 1. So 2 minus 1 is 1. 1 minus 1. 0 minus 1. -1 minus 1. So all of those got plugged up into this function right here. And those are my y values. So then I graph it. Let's graph this piece before we come back to the second piece. So we have an open circle at 2, 1. All of these are ordered pairs, 2, 1, 1, 0. So open circle at that one, 1, 0, 0, -1, -1, -2. And you can see the pattern, right? This is a linear piece, so it's just going to be a straight line going this way. Okay, so we have that piece done. So now we go to the second piece, make another t-chart, but this is going to be for the second equation, which is this. And this one only works for x values that are greater than or equal to 2. So again, we're going to start with 2, but this is going to be filled in because of that equal to sign right there. We want to include 2 on this part of the graph. So we plug in a 2 and then some more numbers that are greater than 2. So 3, 4, 5. And they all, again, get plugged up into this equation. So 2 minus 2, 0. 2 minus 3, 2 minus 4, 2 minus 5. And now we have pieces for the second piece of our function. And we graph those. So 2, 0, we plug that in. It's a closed circle. 3, -1, 4, -2. 5, -3, and we can see the pattern here. This is another linear. And from the equation, we can tell that it's going to be linear. So connect that, straight line, and it's going to keep going that way forever. And there we go. We just graphed our piecewise function. And it passes the vertical line test because if I run a vertical line even through that point right there, it still passes because this is an open circle, and so it doesn't count. That doesn't count as a touch. So passes the vertical line test. It is a function. So we're going to go to example 4, skipping 3 for now. We're going to example 4, and we're going to do the same thing. So here's our function here. If you want to pause the video and try it and then check your answer, that could work. All right, I'm going to start with this first one. This is only for x is greater than 0. So starting at 0, but it's going to have an open circle when I plug in a 0, and then greater than 0. So we'll plug in a few. This is for 2x plus 3 is our equation for this one, our expression. Okay, so plug in all these numbers. So 2 times 0 plus 3, 2 times 1 plus 3, 2 times 2 plus 3, 2 times 3 plus 3. There's the first piece. Open circle, 0, 3, 1, 5, 2, 7, 3, 9. There we go, linear. And then the other piece of this function, which is this one, another XY chart. And this time I'm only plugging in numbers that are less than or equal to 0. So equal to meaning we're going to have a filled in circle for this one. Okay, less than, so we need to go less than 0. So plug in a 0, 3 times 0 minus 2, 3 times negative 1 minus 2. 3 times negative 2 minus 2. 3 times negative 3 minus 2. Okay, so then we graph this. 0, negative 2, closed circle this time. Negative 1, negative 5. Negative 2, negative 8. And the other one doesn't fit, so there we go. And again, it passes the vertical line test, so it is still a function. Okay, let's keep graphing. Let's go to example 5. Graphing this one. So this one you can make a t-chart, just like normal. So I can take like this function right here, make a t-chart for it. 1 over x. And this is for x less than 0. So starting with 0, that would get an open circle. Less than, so negative 1, negative 2, negative 3. So we can plug that up into our function. 1 divided by 0, that's undefined. So we won't get our open circle there because it doesn't even exist there. Negative 1, negative 2, negative 3. Okay. There we go. There's that part of the graph. So negative 1, negative 1, negative a half, negative a third. So, and then at 0, it doesn't exist. But what it would really be helpful, you can use your calculator to help you, and you can plot, you can graph that, just 1 over x in your calculator. But if you remember that parent function, this is the rational parent function, which looks like this. We have those two pieces. So like if you think about it, if you know what that looks like already and you know, okay, I only want the piece of this graph that's less than 0. 0 is your cutoff right here. So less than 0 would be anything to the left. So it's the left side of our graph is what we want. So I can just like automatically know that this is the other piece of the function, even though I didn't plug in numbers to make it look like that. I know that's what the graph looks like because I know what the parent function looks like. So knowledge of those parent functions can be really, really, really helpful. So same thing here. This is another parent function, the square root. But again, if you don't remember what it looks like, you can use your calculator or you can just make a chart and plug in some numbers. Greater than or equal to 0. So we'll get a filled in circle here. 1, 2, I would plug in a 4 because square roots don't give us super nice numbers for everything. So 9. Okay, so square root of 0, square root of 1, square root of 4, square root of 9. I mean, you still can plug in like a 2 and a 3 and whatever, but you'll just get some decimals. So square root of 2 is 1.4-ish. It just makes it a little bit harder to graph. So 0, 0, filled in circle, 1, 1. 2, 1.4, so that's like right here. 4, 2, 3, 9. So there we go. There's the second piece of our graph. And it's a parent function. So if you knew what the parent function looked like, then it'd be easy peasy. And it passes the vertical line test. So good to go. Okay, this one, same idea, but we have 3 pieces this time. So this time I'm going to be plugging in numbers less than or equal to 0. So I plug in a 0, I'm going to closed circle. And less than, so we'll do a few less than. So plugging all these numbers into that equation right there. So negative 3 minus 0. Negative 3 minus negative 1 minus negative 2 minus negative 3. All right, so 0, negative 3. Put it on the graph. We can see the pattern going here. And it's like all the numbers less than x, so I know it does go to the left forever. Okay, this next one is just a number, and some people like freak out because it's just a number and they don't know what to do with it, but it actually makes it easier for us. So if I just have a number like so, then this tells me what I'm plugging in between 0 and 1, but not including 0 or 1. And we can plug in a 1.5 if we wanted to. Oop, that's not what I meant. 0.5. But we're going to have open circles on both sides for the 0 and for the 1. So, but what this means is I don't have anywhere to plug in those numbers, so my answer is just going to be 1 all the way down. My y value is just 1 no matter what. It's a flat line. So when we go to graph this, we have 0, 1 with an open circle, 0.5, 1, and then this with an open circle. So it's just a flat line connecting those two circles. So when it's a number, just a regular old number, it's a flat line. And for x, our last one, same idea. We're plugging in numbers greater than or equal to 1, so closed circle, and I plug in a 1, and greater. So 4 times 1, 4 times 2, 4 times 3, and it just gets bigger. So those are not going to fit, but it's okay. 1, 4, plug it on the graph. 2, 8. So there we go, going that way. Passes the vertical line test, so we're good to go. Okay, now we want to practice graphing and then rewriting. We're going to be writing piecewise functions. So back to example 3. So graphing this guy right here, the absolute value parent function that has been shifted up 5. So again, you can plug in your calculator, but if you know what the absolute value function looks like, just shift it up 5. It's the v. So you just move it up 5, and there we go. We don't have to waste time using our calculators. We can just write it like this. Okay, so we have graphed it, but now the next thing they're asking us to do is to rewrite this as a piecewise function. So breaking this into pieces. So this is going to be my first piece. So it's just going to be a straight linear function. And then this is going to be my second piece, also a linear function. So we're going to put two linear functions together to represent this absolute value function. So first things first, let's look at this guy. And it's linear. So my parent linear function is x. So we can either like take the x and then figure out like what transformations happen to this to get it to look like this, or you can go back to our linear freshman days of y equals mx plus b. So if I just know what the slope is and what the y-intercept is, then I can write my equation pretty quickly. So looking at this, and I'm only, again, looking at this side of the graph. So my slope is just rise over run. So rise over run. So negative 1 over 1, negative 1 over 1, negative 1 over 1. So negative 1 over 1, or just negative 1, is my slope. And then the intercept, it crosses the y-axis or touches the y-axis at 5. So there is my first expression. There's the equation, or y equals that, for the first part of this graph. So negative 1x, or just negative x plus 5. But remember, for the equations, you have to tell also that's the equation for which x values. So if you look at this side of the graph, this for the x values goes the farthest left. It goes left forever, but the farthest right it goes is all the way up to 0. It stops here. So if you project this down onto the x-axis, it stops at 0. So that's the farthest it goes. And we can include this point. You have to decide whether you're including that point on the left part or the right part, but let's include it on the left. Okay, so this is for all x values that are less than or equal to 0. So everything less than equal to 0, because that's as far as it goes. It goes up to 0, and that's it. Okay. And now we look at the right side of this graph. So this side, and we do the same thing. It's still linear. So if we're looking at mx plus b again, we just have to rethink about what that is. So m, rise over run, up 1 over 1, up 1 over 1, up 1 over 1. So it's 1 over 1 for our slope, and then the y-intercept is still crosses the y-axis at 5. So there's our equation for that one, mx plus b. And then this is for the right side. So these are for these x values. But since we use the equal to up here, we can't use that again. So this is just for all the x values greater than 0. And there we go. There is our function, piecewise function. Okay, let's do the same thing down here. But we have different types of functions this time. So we have, on the left, we have a linear, which we can write the equation the same way we did before. And on the left, or sorry, on the right side, we have, sometimes this is a little bit harder to identify. It's not a straight line. You have to think about what are the parent functions. We have cubic, we have quadratic, we have square root, we have all of these things, but you got to think about it. I'm only taking a piece of whatever that parent function is. And so this is actually half of a parabola. If I had the whole graph, it would look like this. So this is half of a parabola, which is an x squared function. It's a quadratic function. So we got to remember that as we're writing our equation. So f of x equals, so starting on the left, we have a linear, so mx plus b. So looking at the slope, we have rise over run. So down 2 over 1, down 2 over 1. So down 2 means it's a negative 2 over 1, which is negative 2. And it crosses or touches the y-axis at negative 2. There we go. There's our first equation. Negative 2x minus 2. And this is for what x values? So looking at our x, it goes left forever, and then it goes all the way until we get to this point right here. But it's an open circle. So up to, but not including that number right there. So for all the x values that are less than 0. Okay, now we have the right side, which we talked about is x squared. And this is actually like the x squared function, like it didn't move right or left. My vertex is still on 0, 0. So then that is it. X squared is my equation for that part. But I'm only using the part that is greater than or equal to 0 for the x values. So there you go. It didn't move, it didn't shift. We have one later where it does do some shifting, so we'll have to rewrite our equation. Okay, try this one out. Pause the video. And then try this, since these are both linear. It's going to be mx plus b again. Slope from point to point, up 1 over 2, up 1 over 2, up 1 over 2. So 1 over 2. And then this crosses the y-axis at positive 2. So there we go. There is my first equation, mx plus b. And this goes all the way over to x value of 4, but not including, because there's an open circle there. So for all x values that are less than 4. And then we have this guy on the right side, mx plus b. So slope, it looks down 3 over 1, down 3 over 1. So it looks like negative 3x is our slope, is negative 3. And then where does this cross the y-axis? It's kind of a trick question because it doesn't cross the y-axis. However, we have to figure out where it would, if it kept going, where would it cross the y-axis? So up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. So it would cross at 10 if it did keep going. So that still counts. We still have to put that as part of our equation. And so this is for, it's filled in, so I do the equal to part, since it's a filled in circle, greater than or equal to 4. And then we have our last one down here. This is in 3 pieces. So we have our linear right here. So this is going to be an mx plus b. We have the middle one, which is definitely not linear. This is some sort of x squared function. And then we have another mx plus b over here. So let's start left to right. It's kind of usually how it goes. So left to right, I'm going to make a bigger bracket. It's not a very good bracket. Bigger bracket, because we have 3 pieces to write this time. Okay, mx plus b, rise over run. So, oh my goodness, from here to here, up 8 over 1. Good heavens. So 8 is our slope, 8 over 1. mx plus b, and b is 0, so I don't even have to write plus 0. Crosses the y-axis. Okay, And this is for, ooh, we have 2 endpoints this time because it doesn't go past this point and it goes all the way to this point. But remember, we're looking at x values. Also, we only saw this one other time on these notes, but when you have an endpoint on either side, you have to put the x in the middle, and then you're going to have 2 less than symbols to say like what your x values have to be between. So lowest is going to be -1, and it's a filled in circle, so we're going to use the equal to part. The right side, the highest x value is +1. And again, you can decide if you want to do the equal to part here or on the next piece. But we'll just do it here. We'll keep track. All right, the next part. This is an x squared. This shape right here is an x squared piece. But if you notice, the vertex of an x squared is normally on the origin, but it's not anymore. So that means that this x squared function has been moved to the right 4 and down 1. Everything else looks the same as the original function, except it's just been shifted to the right and down. Meaning when I write my equation, shifting to the right means I put parentheses around my x, and right means I go -4 on the inside of the parentheses. And then down 1 is putting a -1 on the outside at the very end. So there we go. There is our equation. And again, looking at that curved piece, I have 2 endpoints. So I have to do this with a less than sign on either side. And this goes from +1, and I already used the equal to, so I can't do that again, all the way up to +6. And again, you can decide whether you want to do the equal to here or on the next piece. And last but not least, we have our mx plus b. Over here are linear. So rise over run is down 2 over 1, so -2x. And then this one's going to be a little bit tricky to figure out what the b is, plus b, because I keep going up 2 over 1, up 2 over 1, up 2 over 1. It doesn't fit anymore. 5, 6, 7, 8, 9. But I've gotten up to 9 so far. So if you just know what the pattern is, it goes up 2 over 1 every time. And I only have to go over 1, 2, 3 more times. So I have to go up 2, 3 more times. So you just add 6 onto what we've got. Or you can just like keep drawing it if that would help you do it more. So if we get all the way up here, that would put us way up at +15. And again, we've got 2 endpoints, so this is going to be between 6 and 7. And I already used the equal to sign on the 6, so I can't do that again, but the 7 needs an equal to because it is